Hey guys, welcome back to Math by Saba. Before we start, don't forget to hit the like button and subscribe to my channel. Today we're going to talk about quadratic functions. This is the second part of quadratic functions, so do not forget to watch the first part first. Today we're going to talk about the discriminant of a quadratic function. There is a symbol we use to show the discriminant, and its name is delta. Delta is a factor that we calculate using A, B, and C. Here is the formula for the discriminant, b to the power of 2 minus 4ac. We use the discriminant to calculate the zeros of a quadratic function. Zeros are points that actually are the intersection of our graph with the x-axis. So, um, a quadratic function can have two zeros, one zero, or no zero. For finding the zeros of a quadratic function, we have many ways to do it and to calculate it. One of them is to calculating the discriminant. About figuring out the zeros of a quadratic function, we're gonna discuss it in details in other videos on solving quadratic equation. But here, there's a quick scan of it. So when we makes our whole function equal to 0 and finding the zeros here by finding the discriminant, we can know the exact amount of the zeros of the function. But here we're gonna know what discriminant gives us, what kind of data it gives us without calculating the exact amount of our zeros and we're going to see how our graph will be by calculating only the discriminant, not the amount of zeros. Okay, when we have the amount of the discriminant or delta greater than 0, it means our function, our quadratic function, has two zeros or two real roots. There are multiple um, vocabularies to use when we are talking about zeros or roots. It's important to know all of them. So, when the delta is greater than 0, we have two zeros or two real roots. When delta is equal to 0, it means our quadratic function has only one zero, or our quadratic equation has only one real root. When delta or discriminant is less than 0, it means our function has no zeros. It doesn't have an intersection with the axis of x. Another thing that helps us to know more about the graph of a quadratic function are two factors, p and s. P stands for product of the roots, and S stands for sum of the roots. Imagine your quadratic function has delta greater than 0. We only talk about P and S, product of the roots, and sum of the roots when we have delta greater than 0. When we have delta greater than 0, it means we have two zeros, x1 and x2. P is the product of these two zeros, and S is the sum of these two zeros. But we said that we don't want to know the exact amount of the zeros. So again, by getting help of factors A, B, and C, we can calculate the amount of P and S. P is C over A, and S is negative B over A. These two tiny formulas help us to know again more about how our graph will be. Sometimes we have the graph and we want to know more about the properties of our quadratic functions. But sometimes we have the equation of the function and we want to know more about the graph. What we learned today and what we learned in part one of the quadratic functions video help us to know more about the graph when we have the equation or more about the equation and the roots and the zeros when we have the graph. A question may be raised here that when we can know the exact amount of the roots, why is it necessary to know all of this? But the answer is sometimes in some question, with one of these tips, you can solve the problem very quickly. It doesn't have to, you don't have to use them all to solve that problem. So it's better to know your quadratic function well, and then you can decide when tip you use, when equation to use to solve the problem as quickly as you can. Now, let's solve these examples together. In the first one, we have a graph here. We know that this is a graph for a quadratic function, but we don't know anything else about it. Let's get as much information as we can about the equation of this graph. Let me zoom in. Okay. This graph has two zeros. So we know that the delta of this equation of this function is greater than 0 because we have two zeros. And it is concave down, so we know A is less than 0. So we have a maximum amount here. Okay. What do we know? We have a C here. We know that the y-intercept is always representing C. So C is again negative because it is below the axis of X. And okay, let me draw the axis of symmetry. We know that the equation of this axis of symmetry is negative b over 2a, and it is in the negative part of x-axis. So this whole expression is less than 0. We already know that a is less than 0. So a is negative, and we have a negative in here in the expression. Negative to negative is positive, so B should be negative. To make our total expression negative, we should have um, odd number of negatives in an expression to make the total expression negative. So we have 2 here, and B should be negative, so we make the whole expression negative. So we know that B is less than 0 as well. Let's talk about S and P. We have 2 zeros, so we can talk about S and P. S was the sum of 2 amount of zeros. We know both of these amounts are negative, so S will be negative as well. Another way to say that is the formula of of S was negative B over A. So B is negative, A is negative. As a result, S is negative as well. What about P? P was C over A. C is negative, A is negative, so P will be positive. And we can also say x1 is negative, x2 is negative, negative to negative. It makes the product of the zeros of the roots, so P will be positive. This is all the information we can get just by looking at the graph of a quadratic function. Let's do this one. Again, we have two roots, so delta or discriminant will be greater than 0. One of the roots is in negative part, one of them is in positive part of the x-axis. I wanna figure out the sign of S and P first. Okay, this was the sum of these two uh, roots. We know that sum of the two amounts has the sign of the larger amount. This one has the larger amount. This part is much greater than this part. So our larger amount is negative. So the sign of sum of these two amounts will be negative as well. One of them is negative, one of them is positive. The product of these two will be negative. Here is the sign of S and P. Let's do A, B, and C. It is upward. We have a minimum amount. So A is positive. C is here. Again, C is negative. And what about B? Let's draw the symmetry line. The equation is negative B over 2A. The total amount is negative. B, we don't know the sign of B, but we know that A is positive. We should have B positive again to make this total expression negative. So B will be positive. Here is how you can analyze the graph of a quadratic function. In this one, we have the equation, but we don't have the graph. We want to know as much as we can. We want to figure out as much as we can from the equation without calculating the exact amount of the zeros. Okay, A is -1, B is -5, and C is -4. Because A is less than 0, it means it's concave down, so we have a maximum amount. B is -5 and C is -4. We have to calculate delta. Delta is B squared minus 4AC, which will be 25 minus 4 times -4 is positive 16 times -1 is 16, which gives us 9. 9 is greater than 0, so we have two zeros. S is negative B over A, which is 5 over -1, -5, less than 0. P is C over A, -4 over -1, which is 4, greater than 0. Because P is greater than 0, it means that our zeros should have the same sign. Both of them should be positive or both of them should be negative. But the sum of them is negative, so both of our roots should be negative. They're both here on the negative side, a part of the x-axis. And last but not least, let's calculate the equation of symmetry line. -5, -5, which is +5, over -2, -2.5. Okay, let's draw what we know here. We know C is -4. We know the symmetry line should be somewhere like this. And we know our graph is concaved down. So maybe it's something like this. We should continue to, yes, something like this. This is all we can figure out about this graph. Here it is. Now you know all about quadratic functions and graphs. See you in the next videos.